Hello again, and welcome to another pre-lab video for Chem 106 Lab. The lab that we are talking about here is the first non-qualitative lab of the semester. That is the colligative properties lab, or better known as the determining weight by freezing point depression lab. Now, for this lab, you're going to need a couple of things that you may not have had in the past, or may not have had to use since Chem 105. One of those things is you need Logger Pro. So I am going to split you into groups of 2 and 3, and one of you needs to have Logger Pro downloaded to your device. So the way to do it is, if you have a Windows device, you'll use this link right here. If you have a Mac device, you'll use this link right here. If you are using a Chromecast or some other kind of web-based or Linux-based computer, you're not going to be able to download the program. And so you'll have to rely on one of your partners to do the data collection and to share the data with you when that time comes. So that's the first thing. In your pre-lab preparations, if you are able, get the software onto your program, onto your computer. It's going to help a lot. We're going to use Logger Pro a couple of different times this semester, so might as well download it and make sure that it's available to you so that when you need it, you have it. And that way you can also look at your data and analyze it after lab should that need come about. So that's the first thing that you want to do. Experimentally, this lab is very easy to set up. You're going to have a pair of beakers. One of those beakers is going to be a hot water bath. So you're going to need a largish beaker, probably a 250, full of water. And just getting that up to a really high temperature, boiling it if necessary. And the main purpose of that hot water bath is to melt the solid. So you're going to be measuring 3 different solids, 1 pure solid and 2 solid mixtures, and the hot water bath will melt that solid for you. The other beaker will be a beaker, again, in the 250 to 400 size, that is full of room temperature water. Now, this can be tap water. It does not have to be deionized. In fact, neither of them have to be deionized. What is important about it, though, is that it needs to be enough water that it'll completely cover the solid. And what you're going to do is you are going to be testing the freezing point of that solid mixture inside of this by simply moving that probe up and down, up and down, up and down inside of that test tube. And what you're trying to do is effectively you're trying to get it to freeze inside of that solid. So at some point, the solid mixture is going to fully crystallize. It's going to freeze around that temperature probe. And the purpose of the Vernier software is so that we can basically monitor the temperature throughout the entire process. And so you're going to do this experiment in 3 parts. The first part is where you're going to do the determination of the pure lauric acid. So you're going to be looking at a pure solid substance, lauric acid, and you're going to measure the freezing point of that pure solid. The second part is you are going to measure the freezing point of the lauric acid with benzoic acid mixed in. The purpose of this particular procedural step is we want to see how far down the freezing point comes as a result of being a mixture and having those extra intermolecular forces present. And as a result of that lowering of the freezing point, we can look at what is the composition of that mixture, and we can work backwards to figure out the value of the freezing point constant for lauric acid, the Kf for lauric acid, by doing so. And then once we've determined what the value of KF is, we can work through a different kind of scenario where I'm going to give you another mixture, and this mixture is going to contain lauric acid and some unknown substance. And we're going to tell you how much of the lauric acid is present, how much of the unknown substance is present, and you'll be able to figure out from how far the freezing point of that solution dips down and the KF value, what the molality of the solution is, and you can keep working through that to figure out what the molecular weight of that unknown substance is. And then we can compare that to what it actually is, and you can do some error calculations as well. So on the data analysis side, you'll see that your data tables here. Here's your data table for part 1 and part 2. So the first part is just the freezing point of the lauric acid. The second part asks you to get your identifier number, the information about that mixture, how much lauric acid's in it, how much benzoic acid is in it, what the freezing point of that mixture is, and what the change in temperature is. And then using that information, doing the calculations to figure out the value of KF. This mimics, if you're interested, the Prelab questions walk you through a sample kind of calculation where you use this data to figure out the value of KF and then figure out the molar mass. You can almost think of this Prelab as this is part 2 and this is part 3. And so if you can kind of follow along with what you were able to do in the Prelab, you can kind of figure out what you're going to be doing in the data analysis section as well. And then same thing for part 3, unknown mixture number. What is the composition of that mixture? What is the freezing point? What is the change in temperature? And then using all of that data to figure out what is the experimental molar mass, and then getting data from me about what is the molecular weight and percent error and so on. Now, to validate that you interpreted your results correctly, I am asking you to post the graphs. Easiest way to post the graphs is simply just to import the file from Logger Pro. So if you go to insert attachment here, you can drop in that file from Logger Pro right into the entry itself. Since this is a group component, notice that you are able to make a group submission, and I strongly encourage you to do so. If you are unsure of how to do that, be sure to ask about that before you get into the lab itself, before you start getting into the procedure. Chances are somebody in your group will know how to do it. And then finally, to share all the data with each other. Easiest way to do that is if you go to the page itself here in the Lab Archives bookmarks here. If you right click on that data and analysis, it'll give you the option to share the entire page. So once you've done everything for this particular page and you're ready to submit, you can do this sharing piece, put in your email addresses of the people that you worked with, and just freezing point data, and you can hit send. They will get an email about it. When they click through the link in the email, the notebook page will show up here in their inbox. Right now mine is showing empty because the only thing in it is this, but it will show the other notebook as being there. And then from there, they can move that notebook page into their notebook so that they can start using it. So that's a brief overview of what this lab is all about. Again, the big kind of key takeaways that you want to do is make sure that somebody has Logger Pro. make sure that you are interpreting the data correctly. And so one thing that you're going to notice is that this in procedure one, the freezing point is going to be very flat as far as a graph is concerned. And so you can use the statistics tool to basically see, okay, what is the temperature in that really, really flat region, and mark that down properly. In the part two and part three, mixtures of solids do not freeze at a uniform temperature, because basically what happens is as part of the mixture freezes, the remaining part of the mixture gets more concentrated and will freeze at a lower temperature, and will continue to do so, continue to freeze at a lower temperature until it's all frozen. And so you end up getting a graph that this is a little bit dramatic, but you get a graph that's kind of like this, where you'll see that it is going very, very, very steeply in terms of temperature change. And then that temperature change doesn't level off, doesn't flatten, but definitely slows down. And what you're looking for is kind of that inflection point. Where does the freezing point change from changing drastically to changing moderately? That's the point that you want to record as the freezing point of the mixture. So anyway, that is all that I'm going to talk about for this one. I'll give another